Not your pod for now. You'll join it later for the exit ticket. I just want to get started on our notes. Mohammed, you are most definitely in the wrong class, VP. This is calculus. Okay. Areas between curves to the y-axis. It is May 19th, 2021. So we have been doing, just do a quick review. I have an x-axis and a y-axis, and I draw two curves. Let's draw one in green, and I'll draw one in purple. And let's say green is f of x, and purple is g of x. How would I find the area of the green and the orange shaded regions? The area between those two curves. What would I do?
You find which functions on top and then minus by the other one. We have to take the integrals of both of them.
Exactly. So first we're going to see which function's on top and then just subtract the integral of the other one, right? Because when I take the integral of the green curve to the x-axis, I'm finding, actually, you know what, let's not talk about A or B. When I take the integral of the green function, then I'm finding this whole area up to the x-axis. And then if I were to find the integral of the purple function of g of x, I'd be finding this area under the x-axis. So if I subtract the two areas, then the only thing I have left over is that area in between them, this area here. Okay, the same concept. Notice when I was coloring those areas, I was coloring the areas vertically, right? You're making like little vertical rectangles. If this were a Riemann sum, you'd be making vertical rectangles to the x-axis and adding all those little rectangles up together. That's how we find Riemann sums. But I could also find the area horizontally. So if instead, and there are cases when you want to do this like a horizontal area, you can use both methods, it doesn't matter. But if instead I wanted to find the area to the y-axis, the horizontal area, you would do the same concept. So instead of finding a rectangle like this to the x-axis, I would be finding a rectangle from like this intersection point to the y-axis, from here, where the function is to the y-axis, from here, let's say from here, and here, and here. So it's the same concept, except instead of finding vertical rectangles, today we're going to practice finding horizontal rectangles. Instead of going to the x-axis, we're going to go to the y-axis today. Okay. All right, that was just like a little introduction of what we're doing. Let's actually figure it out. I'm going to give you a real example, one that we can actually calculate. So let's say this is x and this is y. Let's start with one function first. Let's say I have this function here. This function is y equals 15 over x. And instead of finding the vertical area, I want to find the area from this point here, which is e cubed, to this point here, which is e. I want to find this area in between. So this poses a little bit of a problem. If you were to see this and you were trying to find the vertical area, so what you would do, probably, my guess, is that you would take the integral of e cubed dx, find that, and then subtract the integral of e dx, find that. You would be able to get an area, but it wouldn't be perfect because you'll notice that the endpoints of these integrals are not the same, since that second boundary line is a curve itself. It's not like a straight line. What would be much easier and more straightforward is if instead of finding that vertical area to the x-axis, we found this area, this horizontal area from your curve to the y-axis with e cubed and e as my boundaries, my lower and upper boundaries. Okay. Does that make sense? Kind of makes sense what I'm saying here. So instead of finding to the x, we're just turning that graph around and finding it to the y. Okay. hopefully that makes sense. I hear silence. I'm going to assume that means no one has questions, and that made sense. To do that, the first thing we need to do, though, is we need to make sure everything is in terms of y. Thank you, Justin, for that thumbs up. So we're going to rewrite functions in terms of y. And what that means is instead of having a y equals 15x, I really need this to be x equals something y. So y equals 15x. I'm going to multiply both sides by x. And then I have xy equals 15, then divide by y, and you get x equals 15 over y. So instead of having, again, a y equals equation, we're going to have an x equals equation. Once you have that, then you can just take the integral. Just like we would take an integral with respect to x, we're going to take it with respect to y. Nothing else changes. Then take the integral. With y values as your boundaries instead of x values. So remember yesterday when I was telling you to find those intersection points, we only looked at the x coordinate. Today, when we're finding these points, we'll be looking at the y coordinate because everything needs to be in terms of y. So this would be the integral of e, or from e, which is my lower y, to e cubed, which is my upper y. So the integral from e to e cubed of x equals 15 over y, of 15 over y. And this is not in terms of x again, this is going to be a dy. And if you were to plug that into your calculator, just a note, when you put this in your calculator, when you put this into Wolfram Alpha, just switch all the y's to x's. It doesn't make a difference because we've already done the conversion in step 1. Like we already made everything in terms of y in step 1. But when you're plugging in your variables in your calculator or in Wolfram Alpha, it gets really confused if you use any other variables except for x. So just say this would be the integral from e to e cubed of 15 over x, and it'll give you the same answer as if it were y. Plugging this into Wolfram Alpha, by the way, I would get 30 as my answer. Okay. So it's basically the exact same thing as what we've been doing with integrals. You're just taking, but instead of having everything in terms of x, you're having everything in terms of y.
So boil down pretty much anything, like instead of plugging in for x, you plug in for y as your boundaries.
Correct. You just have to make sure that your function is rewritten in terms of x as well. So usually they'll give you the function y equals, just solve for x, get it in terms of x equals, and then make sure your boundaries are the y values and not the x values. You're literally just like, if you can picture it in your head, some of you guys have really great abilities to picture it in your head, but you're literally just taking that graph and you're rotating it so that your function on top is not like horizontal, it's vertical. Thanks, Brandon. Thanks, Justin. Thanks, Naomi. Thanks, Jade. Thanks, Christian. Thanks, Mohammed. Why are you here? Go to your class. Thanks, Raiden. Thanks, Yvette. Guys, we have like, Mohammed, this is my Mohammed from 9C. We have a freshman in our class right now.
You're trying to get a head start, miss.
I love it. I love it. You can stay here if you want. No, you really can't. You have to go to your class or else I'm going to get in trouble holding you here. Thanks, Yvette. I'll see you later, honey. Okay. If there are no questions, let's do a proper example. You'll notice that that was just with one curve. You know, of course, with these questions, we're going to ask with 2 curves. So this is probably more representative of what you would see on the exam. This is my x, this is my y. Let me do a function in green. Let me do a function in purple. And I'm going to call this f of g of y in purple and f of y in green. Okay. I want to find the area between f and g. Now you can do this two different ways. You can take this with respect to x, right? So I could find the vertical distance with respect to the x-axis. You would just have to cut this up. Oh, this is a little awkward. You would just have to stop here. Like this would be one of your boundaries, and then this side would be a different integral, right? Because over here, your purple's on top, and then over here, your green is on top. So you could absolutely do this the normal way, but we are going to do it with respect to the y-axis. We're going to do horizontal areas. And the reason we're doing that is because we're going to be given the equations as x equals equations instead of y equals equations. So since they're already in that format, instead of, converting it back to y equals and then taking it in terms of x, we'll just stick with the format that it's already in. So I'm looking for this area here. And I want to find horizontal rectangles. So basically from here to the y-axis. Okay. And then again on this side to the y-axis. You're going to want to find those horizontal rectangles from your function to the y-axis. My function g is given as y squared plus y minus 1. So again, this is like an x equals equation. It's already given to you. You don't have to convert it. And my function f is given as negative y squared plus 3y plus 11. When I look at this equation, what do you think would come? Like I'm going to be subtracting them just like I find the area with respect to x when I find those vertical rectangles. But what do you think would come first, your g or your f? Like which one would you be subtracting from the other? See if any of you guys can rotate this in your head.
I would say G, since G is to the left, so it's closest to it's on top. Like if you were to rotate it, it'd be up top.
Not quite.
It'd
It's
be
actually
F.
the exact opposite. What do you think, Christian?
Would it be F?
It would be F. So remember that the positive direction is to the right. So Brandon, your instinct is correct. We have to look at the direction and we have to rotate it. But the positive direction is to the right. So to rotate this, can I rotate this? No, not that fancy. Can I rotate this? Nope. To rotate this, I would rotate the whole thing I would be rotating it counterclockwise. So like this point here would come on top. This point here would be the bottom. Does that make sense?
Yeah, that makes sense.
And that's because this is the positive side. So the positive side would go on top and the negative side on bottom. So Christian, your instinct is correct. F of y would come first. So this would be the integral. To find that area, the horizontal area, it would be the integral of f of y minus g of y with respect to y. And then all I have to do is figure out my endpoints, which is where they intersect. So from this intersection point down here to this intersection point up here. Now this is the key. Your calculator can only graph in y equals. So if you're using a graphing calculator, put it down. You're going to have to use Desmos for this because graphing calculators cannot handle x equals equations. They can't graph it. And you wouldn't be able to find the intersection unless you solved it some other way. So what I'm going to do is go to Desmos. I promise I'll come back to this screen if you still need to copy. It's all right. I'm going to go to Desmos. Graphing calculator. And then when you are in Desmos and you are graphing, so like I said, with Wolfram Alpha and with your graphing calculators, when you're just finding integral values, keep everything in terms of x, that's fine. But when you're graphing, make sure that you actually have it in terms of y. So f of y is negative y squared plus 3y plus 11, and g of y is equal to y squared plus y minus 1. And that's because this is very specifically an xy coordinate plane. So if you substituted x for y, you would get different graphs. We want to make sure that the graph itself is in terms of y. My intersection points are at 1, -2 down here, and 11, 3 up here. Okay. And of course, when you do graph it, you can also see that that f of y is more positive. When you rotate it, the f of y would be on top. All right, I'll share my iPad screen again. Ah, yes. Okay. So the boundaries for this integral, remember when we do it with respect to x, we look at the x values. When we do it with respect to y, we have to look at the y values. So my boundaries are going to be from that -2 down here to that +3 up there. And when I put this into Wolfram Alpha or my calculator, I'm going to use Wolfram Alpha really quick. Integral of, make sure you use parentheses, or you could do it separately like you guys, like you could still do this separately. You could do the integral of f first and then subtract the integral of g next. That's fine. Just make sure you use parentheses for it. X squared plus x minus 1 from 2 to 3. My Wolfram Alpha tells me that the integral, yep, is 41.667. Any questions on this? With almost all graphs, you kind of have the option of doing it either like a vertical integration or a horizontal integration. You just do whichever one feels easier to you for that particular graph. But sometimes they will specifically ask for like, what is the, if you like cut this graph in half horizontally, what would your integral be? Then in that case, you need to do it with respect to y. If they ask what, if you cut the graph in vertically, then vertically means with respect to x. Maybe I should write that down. I'll write that down. So horizontal integral is y, vertical integral is x. That's the only time when they specify that you don't have a choice. So horizontal equals y and vertical equals x. Otherwise, almost all integrals, you can do it either way and you should end up with the same answer. And a lot of times I actually find doing the horizontal integrals are easier because like if you notice in this particular question, if I did the vertical integral, I would have to do it twice because I would have to find this area where g is on top and subtract f. And then I would have to find this area where f is on top and subtract g. I'd have to do it twice, which is kind of annoying. Alrighty. Any questions? Are we done with this page? Give me a thumbs up. I see Naomi's thumbs up. Thank you. Thanks, Raiden. Thanks, Jade. Thanks, Brandon. Thanks, Adiani. Thanks, Christian. Thanks, Yvette. Thanks, Brandon. Okay. Do we want to see another example, or you guys want to just do the exit ticket? Thanks, Justin. Practice problems on your own time. What do we think?
Maybe another example.
All right, let's do another example. Okay, I'm going to insert a page. This example, this is the exact same graph from yesterday, except we're gonna do a horizontal area instead of a vertical one. And this is what I mean where you have a choice. So I had this funky triangle looking shape. This was 1, this was 5. This intersection point was like, I think, I don't remember what it was. 3.693, 1.3006, right? Okay. This line was y equals ln of k. And this line over here was y equals 5 minus k. Or 5, not ln of k, I can't read my own writing, ln of x. And this was 5 minus x. Okay. And this was the region R. So I'm looking for this shaded region in between the two curves. I can absolutely go over Wolfram Alpha, yes. Okay, so yesterday when we took this integral, we noticed that neither one of these lines was on top of each other. So all you had to do was find the integral of ln of k or ln of x up until that point, and then add the integral of 5 minus x from that point to 5. Right, you guys remember that from yesterday? So yesterday we found that neither one of these lines is really on top of each other. So you just had to take one integral up to the intersection point and the other integral up to from the intersection point to 5 to find the total area. Another way to do it, if instead we wanted to use just one integration, is we could do a horizontal area. So instead of finding those vertical little boxes to the x-axis, we can find the horizontal rectangles in between to the y-axis. And when you do that, you'll notice it's only one integral. Which of these would be on top?
Five minus x would be the top.
Yep. When I flip this, if I were to rotate this in my head so that this point were over here and then this line were on top, then the 5 minus x would be on top. It is the most positive line. And then the ln of x would be on the bottom. So your integration should be this function minus this function, right? Thing is though, these functions right now are in terms of x, it's y equal forms. So before I take the integral, I just need to make sure that they're in x equal form. So y equals 5 minus x, when I solve for that x, turns into x equals 5 minus y. And then y equals ln of x, when I solve for x, you're gonna take e, like raise both sides with a base of e. The e and the ln cancel out and you get x equals e to the y. Now that you have both equations in terms of y, you just find the area integral. You take that minus that. So it's going to be the integral of the 5 minus y minus the e to the y with respect to y, because everything's in terms of y. And my boundary is the x-axis, which is y equals 0, up to this intersection point of 1.3006. Since everything's in terms of y, we use our boundaries as the y values. We plug this into Wolfram Alpha. Let me share my screen so you can see how I do that. So this was what I did for the previous integral. In Wolfram Alpha, I wrote integral of the first function in parentheses minus the second function in parentheses from -2 to 3, my boundaries. And notice that I just converted the y into an x because Wolfram Alpha is a little dumb and I don't think it can handle it if you did it in terms of y. Again, it's okay when you're taking integrals to have it in another variable as long as everything's in terms of that variable. It's just not okay when you're graphing. When you're graphing, you have to have it exactly as is, and you have to use Desmos to graph these functions. Okay, for this particular one, I'm going to write integral of 5 minus x minus e to the x. Notice I kept that first one in parentheses. If the second one had more than one term, I would also put it in parentheses. From 0 to 1.3006. Just double check that's exactly what you want. That's the first function minus the second function. And it tells you that the answer is 2.98572, which if you compare that with our answer from yesterday when we took the vertical areas, it should be exactly the same. Yeah. Maybe off by like a decimal point. Okay. Any questions for me at all? Thanks for that thumbs up, Naomi.
My question is, when will we have to like use each of them? Because we can either use the X one or the Y one. When are we gonna be able to
So-
use them?
You can really choose. It's really up to you on the exam, unless they specify. If they say find the horizontal area, or there's a horizontal line that cuts this region in half and write the integral, that horizontal is your keyword for you have to have it in terms of Y. If they say vertical, keyword for you have to have it in terms of X. Otherwise, it's really up to you which one you want to do. Often I find it's easier to do it in terms of X, unless it's an equation like even the one that we just did, our first example, where if you did in terms of X, you would have to cut it into two different areas, or even like the very, very first example where like the boundary was a big long curve and finding it in terms of X would be a little confusing. So it's really up to you all the time, but think about how many integrals you're going to have to take if you have to do it in terms of X, and whether it's easy to turn it into Y. Does that make sense, Brandon?
Yeah, it does.
Yeah, it requires just a little bit of like critical thinking on your guys' end, but it also gives you the flexibility to choose whichever one works for you in that particular situation. Like if you're looking at this question and you saw y equals ln of x, and you forgot how to convert how to get rid of the ln by taking e to both sides. Like if you forgot that, then maybe you just take the two integrals in terms of x, because you don't want to risk getting your function wrong when you're converting it into an x equals equation. On the flip side, if that were given to you as an x equal equation, maybe just take it with respect to y, because you're like lazy and you don't want to convert it. Okay, that's a good question. For your exit ticket, you're going to try it yourself. I made it easy for you. I gave you the equations in terms of x, so please just take it with respect to y. You're just going to practice. But of course, if you wanted to think about how you would take this in terms of x instead of y, you can definitely think about that and try it on your own and see if you can get a matching answer. This is the link to the Nearpod, and the code is UTIAK. I'm going to just share my screen for a sec. And I'll show you again, this is your area. So one more time, I gave that to you. It's an x equals, so just take it in terms of y. But if you wanted to think about how you would do a vertical integration with respect to x, and you wanted to compare the answers that you got, you can go ahead and do that too if you get bored. You should get the same answers. If you took a vertical integration, you would just have to do it twice, versus if you take the horizontal, you only have to do it once.